Welcome to the third module in the series on Simio's search process. So of course the objective of the whole module is to understand how the search step in Simio works and how we can implement it in different simulation models. So in the first video of this module we talked about this model where we have two types of entities, and whenever we hit this button we would like to transfer type B entities to the second server. So if I run the model, you will see that entities pile up in my queue, and then whenever I hit this button, the red entities that are B entities are transferred to my second server. And we did this by using this process that is triggered by a user-defined event called event1, and then we have a search process that finds type B entities, and then a transfer step that transfer type B entities to the second server. So the important related topics to the first module were tokens and entities, user-defined events, buttons, and queue states. So these are all covered in the first video of the module. In the second video of the module, we talked about this Simio model, where we have again two types of entities, but this time after the entities are created, they are transferred to a standalone station. So if I go to my definitions of my model, I have a holding station, which is a standalone station that I have defined, which is represented here. And whenever I hit the pull A button, I pull the green entities out of, or type A entities out of my station and transfer them to process A. Whenever I hit the pull B button, I transfer type B entities to process B. So we talked about this model, and we talked about its different processes, the transfer steps from the source objects to the station, and also the search processes. So the important related topics to the second video of the module are stations and detached queues. So in this video we're going to learn how we can search up to a limit. So this is the complete version of the model that we're going to build in this video. So as you can see in this model, my entity realizations have a size which is a model entity state variable. So whenever a type B entity is about to leave the system, I only want to pull type A entities out of my standalone station up to the size of my type B entity that is about to leave the system. So in other words, the sum of the individual size values from my type A entities that I pull out of my station and transfer to the process A station should be limited to the size of the type B entity that triggers this transfer process. So in this case, since the sum of these values are less than my limit, 15, all of them will be transferred to my processing station if I continue running the model, and that's what happened. So I have a breakpoint here, so whenever a type B entity is about to leave the system, the model is paused. So in this case my limit is 40, the sum is less than 40, so if I continue running, all of them will be transferred. And finally, in the third case that I'm going to show you, my limit is 15, the sum of these values is greater than 15, so only some of them will be transferred after I hit run. So I'm going to hit run now, and some of the entities were transferred, and I only pulled out of my standalone station up to my limit. So let me go back to my slides here. One of the things that we need to learn in order to be able to implement this logic is the notion of user-defined tokens. So that's the important related topic that we're going to cover in this video. So before I talk about the details of the model that we're considering in this video, I would like to do a very quick recap on what we covered in the previous videos of this module. So we talked about tokens and entities and the fact that Simio processes are run by tokens. So for example, in this particular example, a model entity visits an object that triggers an add-on process. So the process is run by a token, and the associated object to that token is the model entity realization that triggered my add-on process. And of course, the object that it's visiting will be my parent object. We also talked about the details of the search step and its different properties, such as queue states and match condition and limit. We talked about the details of the process that we had in this model. So whenever we hit the remove B button, a token is created that executes this process. So when I get to my search step, I have 8 realizations of type B entities in my queue. So 8 tokens will be created, each associated with one of these realizations. And my process just continues to be executed. So the tokens are processed one by one, and my entities or B entities are sequentially transferred to my other location. And this process will continue until all of my type B entities are transferred. So if you're not familiar with tokens, the basic operation of the search step, its different properties, queue states, the expression for the match condition, and specifically the candidate component, and the other properties of the search step, you should definitely go back and start from the first video of the module. So let's have a closer look at the model that we're considering in this video and talk about its different components in more detail. So in this model, each model entity realization has a size value associated with it, which is a model entity state variable. So if I select my model entity and go to its definitions, states, you can see that I have defined this integer state variable called my size, and its default value is 0, but whenever I create an entity, I sample its value. So for example, at my first source, I have this add-on process where I first sample the value of my size using a discrete probability distribution. In my other source instead, I'm using the state assignments. And so if I open my state assignment here, you can see that I sample the size of type B entities right here at source 2. So in this model, I have a standalone station, and whenever I create type A entities, I transfer them to this station. So right here at the add-on process for my source 1, I have this transfer step that transfers type A entities from their current station, which is a source object instance, to my holding station, which is my standalone station. And then I have the end transfer step to tell Simio to end the transfer. So if I run this model, you will see that type A entities are transferred to my station after they are created. So we covered the topic of stations in the second video of the module. So we talked about how we can define standalone stations from the elements of our definitions tab, and we also talked about how we can use detached queues to animate our station. So if you're not familiar with stations and detached queues, you should stop this video and go back and watch the second video of the module, and then come back and continue the current video. So if I continue running this model, a type B entity realization will be created, and the model will be paused when this entity is about to leave the system. So remember that this time I only want to pull type A entities out of my station up to a limit. So the limit is the size of this B entity that is leaving the system. So in this case, the sum of these individual size values is 14, which is less than my limit, so I expect all of them to be transferred. So if I run in the step mode, you will see that my A entities are sequentially being transferred to my process A server object instance. I also have a status label here that shows what the last limit or last capacity was. And this last capacity state is a model state that I have defined. So if I select my model and go to my model's states, you can see that I have this integer state variable called last capacity. And this is the value that my status label shows me. So if I go to my processes, you will see that I have this process right here that performs different steps that I need to implement this logic in my model. So this process is triggered when a type B entity realization enters my second sink, sink 2. And as you can see, this process is executed by a token class called myToken1. This myToken1 is a user-defined token. So if I go to the definitions of my model and then tokens, you will see that I have defined myToken1 right here, and it has its own states. So I have this total used capacity state variable that accumulates the value as I transfer entities to my server object. And also I have this total capacity that is my limit. So before implementing the model in Simio, let's talk about the details of our add-on process and how its different steps work. So in this slide you can see that I have a screenshot of my model where my limit is 15, but clearly the sum of the size of type A realizations that I have in my station is greater than my limit. So at the end of running this process, I only want some of these to be transferred to my server object. You can also see the properties of my search step here. So I'm searching in a queue state, which is the contents of my station, and I'm doing a forward search. However, this time the limit is 1 because I'm pulling out my A entities out of my station one by one, and each time I want to check whether I have reached the limit or not. So when my type B model entity realization enters the sync object, sync to entered add-on process is triggered, so Simio creates a token to execute this process. And we just talked about the fact that in this model we're using a user-defined token to execute this process. So this is a realization or an instance of myToken1, which is my user-defined token. So this myToken1, this particular one, inherits both of the state variables that I have defined for my user-defined token. In other words, this token has both the total used capacity and the total capacity state variables. So when I execute this process, the first thing I do is make an assignment. So in this assignment step, first I set the value of my token1.total capacity to the model entity.mySize. In other words, to the limit or the size of this model entity. Also, in order to make my status label work, I have another assignment where I store the limit in my last capacity model state. So the token then executes the search step. So in my search step, I'm searching in the contents of my station, and the limit is 1. So I'm just going to pick or select the first entity in my queue because I'm using this forward search type. So a token will be created that is associated with the first type A entity in my station. So my original token will take the original branch, and the token associated with this entity will take the found branch of the search step, and then I go to another assignment where I accumulate my size. So here is my assignment operator. So the new value of my token1.total used capacity, which was initially 0, will now be 2, which is the size of this model entity. So whenever I get to this assignment step, I accumulate my total used capacity based on the size of the model entity of type A that I'm processing. And then my token will execute the transfer step where I transfer the first entity to my process A server. And then I make a decision. And in my decide step, I check whether I have exceeded my limit or not. So in other words, the expression I have in my decide step is my token1.total used capacity is less than my token1.total capacity. And in this case, since this value is 2 and this value is 15, I take the true branch of my decide and I go back and I do another search. So I find the second entity, which is now, after I have transferred the first entity, the first one in my station. So again, my original token takes the original branch, and this token will run the assignment again. So now this time when I accumulate, the new value of my token1.total used capacity will become 4. So before doing this assignment it was 2, and the model entity.mySize for this entity is 2. So now it becomes 4, and then I do the transfer. So I transfer the second one to my queue, and then I make the decision. And so this value is 4, my total capacity is 15. So again, I take the true branch of my decide step. So this process will be repeated for other entities that I have in my station. So this entity will be transferred, this entity will be transferred, this entity will be transferred, this one will be transferred, and when I get to this type A entity, the value of my token1.total used capacity will be 14, which is the sum of the values of the individual size of the entities that I have already transferred. So when the token associated with this last entity executes my process, again I do the accumulation, so the new value of total used capacity will be 16 now. However, I still make the transfer here, so I transfer this one to my queue, but this time my decide step will take the false branch because now the value of my token1.total used capacity is 16, and my total capacity is 15. So this token will take the false branch, and then the process will end. So as you can see in this model, we needed a user-defined token that has 2 additional state variables, the total capacity and total used capacity. And we needed these state variables in order to be able to accumulate our value as we transfer entities, and also to check whether we have reached the limit. So now let's go to Simio and actually implement this logic in our model. So I'm going to start with an initial model that has all of the components already in the model except for the logic to search up to a limit. So now I run this add-on process using just a default token that Simio creates, and then I search all of the entities that I find in my queue, and I transfer them to my server object instance. So if I run the model, you will see that all of these entities will be transferred. If I click on fast forward and get to the same situation we discussed in our slide, where the sum of these values exceeds my limit, in the initial model, if I continue running, all of these entities will be transferred because I still don't have the logic that searches only up to a limit. So now let's complete this model. So the first thing I'm going to do is go to definitions, tokens, and define a new token. So my token 1 is a default name, and I'm going to add 2 state variables to my token 1. So they're going to be integer values. So the first one, I'm going to name it total used capacity. The second one, again an integer, I'm going to call it total capacity. So now I can go back to my process and tell Simio that I want this add-on process to be executed using not the general class or the default class token, but my token 1. Now the next thing I need to do is complete my add-on process. So I'm going to start with my first assignment where I set the value of my token 1 total capacity to my current limit. So my state variable will be my token 1 total capacity, and it will be equal to model entity dot my size. So the current or the size of the type B entity that is about to leave the system. The other assignment that I would like to make for my status label is have my last capacity that I've already defined as a model state equal to my model entity dot my size. So now that I have added my first assignment, I'm going to go ahead and add my second assignment after the search. And in this assignment, I'm essentially accumulating the total used capacity. So the state variable is my token 1 total used capacity right here, and its new value will be its current value plus the size of the entity that I'm about to transfer. So it'll be my model entity dot my size. And finally, after I make the transfer, I need to decide and stop the process if I have already exceeded my limit. So my decide is going to be condition based, and the expression is my token 1 dot total used capacity less than my token 1 dot total capacity. And if this is true, then I would like to go back and search for the second entity in my queue or in my station, and then transfer the second one into my server object instance. And finally, the last modification that I need to make is to modify my search step, and instead of looking for all of the entities, I would like to limit my search to only one entity. So each time I only pick the first one in my station. So now I can go back to my model and run the model to make sure everything is working. So I hit run, fast forward. In the first case, my sum is less than my limit, so all of them will be transferred. If I hit fast forward again, the limit is 40, the sum is less than 40, so all of them will be transferred again. And here in the third scenario, which is our famous situation that we also talked about in the slides, we have a limit of 15, the sum is greater than 15, so if I run in a step mode, we transfer entities one by one up to this entity where the sum of the individual sizes will become 16. So I hit step, so I have 2 plus 2, which is 4, 7, 9, 11, 14, and then this is the last entity that I will be transferring to my processing station. And there it goes. So my sum is 16, my limit was 15, and as you can see, I won't be transferring any other entities. So again, as you can tell, this is not a perfect model in the sense that in a situation like the one we just saw, we may exceed our limit. So this will be a good assignment for you to modify this model such that we never exceed our limit. So we may do our transfer to a value or to a sum that is less than our limit, but we never exceed the limit.